Consider the correlation coefficient choices below. The correlation coefficient that indicates the weakest linear relationship is closest to minus 0.8, 0.35, or 0.65. I'm going to pull in my little cheat sheet table here so we can kind of walk through this. As a reminder on the correlations, we can go from -1 all the way up to +1 as that's our range. So at -1, we're going to be perfectly negative on our correlation, which is still going to indicate a strong linear relationship, meaning that the two variables are going to move exactly opposite of one another over time. Contrasted to that, 1 indicates perfectly positive correlation, meaning they're going to have a strong linear relationship also, but those variables are going to move in the same direction over time. And then lastly, will be 0 or no correlation or low correlation if we're close to 0, indicating a weak linear relationship. And so we're tempted to just choose minus 0.8 here, I think, because it's the lowest number. We think, oh, lowest correlation. But that as you get close to that -1, it's still going to be a strong linear relationship. The variables just move in opposite directions. So we're going to want to choose the answer closest to 0, so we will go with B, 0.35. Question 2. Which of the following is least likely to be a way through which globalization can increase non-state actors' profits? So keyword here is going to be least likely, so 2 of these are going to be answers that would increase profits. So we've got A, reducing costs, B, increasing sales, or C, increasing investment flows. A and B, reducing costs and increasing sales, these are going to pretty directly lead to increased profits right away. I think you could potentially make the case for increasing investment flows, increasing profits more over the long term, just as investment comes into the country and that capital is used to do answers A or B. But since it's the least direct way, we will choose answer C. Chris Suming is analyzing hedge fund performances over the past 4 years. He divided the industry into 2 categories: global macro hedge funds and non-global macro hedge funds. The most appropriate sampling method utilized is systematic sampling, simple random sampling, or stratified random sampling. So systematic random sampling is going to be choosing the population, and our population in this instance is going to be that overall hedge fund category, because that's the performance we're analyzing. So it's going to be taking a sample from that larger population based on some predetermined rule or periodic interval. So every 3rd or 4th hedge fund would get bumped into our sample. Simple random sampling is also going to be taking that overall population and then randomly selecting the different hedge funds to be included in the sample. And each hedge fund must have the same probability of getting into the sample. So that's not going to be consistent with dividing into 2 categories, because we're not randomly choosing these categories. We're doing it based on the classification. So our answer is going to be C, stratified random sampling, because this is the only choice that involves dividing the populations. Next step would be choosing the random sample from each of the different populations so they can look at the performance. But that key really is the dividing into 2 categories. That's going to lead us to stratified. Answer C. Question 4. An analyst wishes to assess whether the economy has reached the peak of the business cycle. Would most likely be best advised to look for indications that A, businesses have slowed their hiring. That sounds like a pretty good indication. If we're just kind of looking at the business cycle here, once we start to get up to this peak here, we're getting to the end of that expansion. And so this is generally meaning that there's going to be lower or less demand or slowing demand. And when you have slowing or less demand, you're not going to need as many employees, or you're not going to need to be hiring as many employees to kind of meet that slowing demand. So A could definitely be our answer. Let's rule out B and C just to be sure. B, businesses have begun to purchase heavy equipment. Typically, that purchasing is going to happen earlier on in the recovery, because this is when demand is going to really start picking up. So businesses need to re-up their equipment and processes and everything in order to kind of ramp up and meet that demand. So we're going to rule out B. Just cross it out just to be sure. And for C, the economy is showing moderate or possibly falling rates of inflation. Inflation is not typically going to moderate or fall until we get past that peak into the slowdown and contraction phases. So we're going to rule out C there too, and we'll go with answer A. Question 5. Zhang is developing a regression model to predict stock market returns using the GDP growth rate. He considers quarterly returns of the S&P 500 as a proxy for stock market returns and quarterly changes in GDP as GDP growth rate. The linear regression model is as follows. So we've got our model here. Zhang develops the following partial ANOVA table and regression statistics based on the last 10 years of quarterly data pertaining to the S&P 500 and GDP. And we've got our table here. The standard error of the estimate for Zhang's model to predict stock market returns using the GDP growth rate is closest to. So we've got our answer down here. So I'm going to start pulling in our formulas here. So we're looking to calculate the standard error of the estimate, which is going to be the sum of square errors over n minus 2. And then we are going to take the square root of that. So to calculate sum of square errors, that is simply going to be this 155 total number minus the 108 number that we have here. So that's going to give us an answer of 47.5. So that's going to go in our numerator up here. And then our denominator is going to be 40 minus 2 for the total number of observations that we have, 10 years, 4 quarters per year. And subtract 2 from that per the formula. Take the square root of all that. We get 1.118. Answer is C. Question 6. S&M Bank's certificate of deposit pays 10% compounded semi-annually. The bank allows the investor to reinvest the interest at the same rate for 2 years. The worth of the CD at maturity, if the investor currently invests $200,000, will be closest to $242,000, $243,101, or $243,680. So I've just got the calculator up here, and I'll walk you through plugging these into the time value of money functions to get your answer. So we'll just go right through the question. We're paying 10%, but we're compounding semi-annually. So we're going to do 10% divided by 2 to get our I, so we'll have interest of 5. We're investing at that same rate for 2 years, but since we're compounding semi-annually, we're going to do 2 times 2 to get our N of 4. Let's see. Worth of the CD currently is $200,000. That's going to be our present value number. And then it doesn't say anything about receiving coupon payments or anything like that, so our payment's going to be 0. Now we've got everything plugged in. Hit compute. Future value, and we can see we've got 243,101. We'll go with answer B. A pension fund manager expects that payments of $1.5 million per year will be paid to retirees starting at the beginning of year 6. They will extend until year 19. The discount rate is 8% compounded annually. The present value of the pension liability today is closest to. All right, so for this one, this is a little tricky, so it's going to be a 2-part time value of money calculation. Part 1 is going to be taking these $1.5 million a year cash flows from year 6 until year 19, and we're going to discount those back to the beginning of year 6. And then from there, we're going to take our answer and then we will discount that back to the present value today to get the present value of the liability today. So let's walk through doing that on the calculator here. So we've got 1.5 million is going to be our payment. And N is going to be 14 because we're doing annually, and since it's the beginning of year 6, we go year 6 all the way through 19, so our N will be 14. Interest rate will be 8, and our future value is going to be 0. So now that we have those plugged in, we're going to hit compute our present value. So this is where things get a little tricky because you see that it's the exact answer that comes up here, so we might see that and just think, oh, we can pick that answer. But we need to take the next step and discount this back to the present value today. So for part 2, we're going to be computing present value again, but we're going to use this 12 million number as our future value to discount that back to the present value. So the nice thing is we already have this up. You can just click that future value number, and now it has that locked in here. We're going to change our payment to 0 because there's no payments during those first 5 years. We're going to be computing present value, so don't put anything in there. Interest rate will stay at 8. And then our N is going to be 5 because we're doing years 1 through 5. And we'll compute that present value, and we get B, 8.4 million. So we need to be careful on the years that we do, though, because if we, because we're starting in the beginning of year 6, we're only compounding 4 or 5 years, so we need to make sure we have 5 as that N number. If we would have put 6 in here, you can see we would have calculated and got answer A. So just something to watch out for there. Because it's the beginning of year 6, we want to make sure we're only compounding 5 years. Question 8. Which of the following is the most accurate definition of a type 2 error? A, rejecting the null hypothesis when it is true. B, rejecting the null hypothesis when it is false. C, failure to reject the null hypothesis when it is false. So I'm just going to pull in our table here, and this is going to be a pretty important table to memorize. So we see here we have a false null hypothesis. Type 2 error is going to be failure to reject that false null hypothesis. So we're going to get answer C. Question 9. Kelly Cronin is one of the statistical experts at CMSSP. He is presently using internally developed software to explain the relationship between a company's EPS growth and profitable opportunities as measured by the spread between the equity return on new projects and the firm's cost of equity. After regressing a sample company's historical EPS on its return spread for the past 10 years, Cronin presented the results to his superior, Brendan Tracy. The following table displays the results of the regression. So we've got our regression results and some statistics here. And then we've got our T-stat table right here. And then lastly, using the information provided in Exhibit 1 and the return spread of 15%, the 95% prediction interval for EPS growth will be closest to. We've got 3 different interval options. So I'm going to start up here just so we have enough room to kind of show work. So for our confidence interval, there's going to be 3 main components here. We've got our prediction, which is going to come from the regression analysis, these coefficients, the spread, and then what the company-specific return spread is. And then we're going to have our critical value, which will derive from the t-table, and then forecast error, which we're going to pull from a specific formula and then basically plug in a bunch of these numbers to it. So, starting with the prediction variable, this is going to come from the regression like we mentioned. I'll bring it down here so we have enough room. So we're going to have EPS growth predicted as 1.207, which is going to be that intercept, and then we're going to plug in the return spread beta here of 22.901, so that's going to go in this B spot, and then we're going to plug in, lastly, the return spread that we're trying to make the prediction on. So return spread of 15%. Based on this coefficient in beta, we can expect EPS growth of 4.6421. So this is going to be our prediction value, 6.4. Let me pull this down so they're next to each other, or you can see them both on the same screen. So that prediction is going to be 4.6421. That'll be our first value here. Critical value is going to be a little easier to derive. We've got 62 observations here, so we're going to take this 60 number, and then the tricky part comes with which p-value we're using. So we'd be tempted to kind of take this 0.05 since we're doing 95% confidence interval, 1 minus 0.95, but we need to remember we're taking 95% confidence. We need to take 2.5% off each tail. So our p is going to be 0.025, giving us that critical value of 2. So now we've got our prediction, 4.6421. We've got our critical value of 2. Last thing we need is this forecast error. And this is going to be derived from plugging in a bunch of numbers from up here into a formula. So let's pull that formula in. So we've got our forecast error squared is going to equal the standard error of the estimate squared. So that's going to be the 1.12 coming from right up here. Standard error of the estimate, 1.12. And then we've got our observations at 62 to give us our 1 over n. And then lastly, this side of the formula over here. So our x is going to be the number we're looking at, and then x bar is going to be our mean. So the mean return spread, 0.0943. We'll square that and plug in n again down at the bottom. And then we've got this variable here is going to be the variance of mean return spread, so 0.007721. And notice we don't have to square that number because they're giving us the variance. If they were giving us standard deviation, then we would need to go ahead and square that. So plug all these numbers in, and we get our 1.282895. Last thing we need to do there is take the square root to get that 1.13 number. So this is going to be our forecast error. So I'm just going to type this out just so we can kind of go through this one last time together and pull it through. So we're going to have 4.6421. Then we're going to add that critical value times that 1.13265. That equals 6.9074. And then we're just going to do the same exact thing, that 4.6421, and then this time we're going to subtract. So we've got 2 times 1.13265, and that equals 2.3768. So finding those values, we're going to have to round up a little bit. So we've got 2.38 to 6.91. So we're going to go with answer A. And just to throw this out there, this is probably a much longer question than you would have to do on the exam. It's definitely good for understanding the formulas and where all the variables come from, but this would take way too long, and they would probably give you one of these variables. They might give you the forecast error on the exam, and then you just have to figure out the prediction and the critical value. But yeah, long-winded way to get to answer A. Question 10. If the significance level of a test is 0.05 and the probability of a type 2 error is 0.25, the power of a test is closest to. So for this, we're going to be using that power of a test formula, which is really quite simple. It's just going to be our 1 minus p, and that p is just the probability of a type 2 error, which is going to be 0.25 in this instance. So we're just going to be doing 1 minus 0.25, which gives us 0.75, answer C.